Hello. Hello, hello. Connor, Rand, hello. Indeed, we have both video and audio, I believe. I think we have the full set. Julian, hello. Matthias, hello. Betty, hello. Quacko, welcome. Okay, get going in a Minuten. Ein Minuten. Grism, hello. Everyone's Sunday pleasant. Thor, hello. Okay, right. Plenty to be done today. I want to try and finish off the last bit of post-processing shenanigans today, with the Bloom being the final one. Final one for now, because then I want to get on to do some profiling stuff, and then physics. I'm kind of a bit torn about physics because, like, obviously we're going to use Jolt, and I'm torn on two points, I guess. One is, do I just lift and shift the stuff from the previous game, or do we rewrite the whole thing from scratch? I'm tempted to rewrite it because I think I learned a lot of lessons doing the last one, and I think there's some very design choices I would change. So I'm tempted just to, and I want to make sure I use their virtual character controller better. So I'm tempted to just spend the time and rewrite it. And the other one I'm kind of the other issue I'm kind of considering is like how to do the collision shapes, because obviously I've got this asset pack that I've purchased, and we could just slap a triangle collider on it, but that's not really particularly like efficient, especially when everything is just corridors. So then I don't know, do I then create like proxy like physics colliders? Do I spend some time and do that like in Blender and draw them all out? Do I make it part of the editor where I can add them? Like, do I then make it like a prefab system? I really so I kind of really don't know what to do with that. I suspect what I'll do is have a separate part of the editor which allows you to add static colliders, and then we'll just draw them as we need them. And then if that becomes a pain, I would then probably go through the effort of then pairing up individual colliders with individual meshes so that we can keep adding them in. But like to draw like, you know, some walls and a floor is not going to be that hard. Famous last words to do. Mystic, hello. Okay, right, let's go into some code, because I have a couple of Is it worth creating static colliders for the geometry? I don't know if it's worth doing that, or if it's worth just adding rando shapes as and when we need them. That's what I'm torn about. It's a big cost, but it's a one-off cost, and then I'll probably be quite glad I paid it. But then maybe I just do that quietly off stream. Maybe do it on stream. I don't know. I don't know. Feels like it's going to be something in a YAML file somewhere. Okay, so the only thing I think I really did off stream, I don't think I've done anything since the last one apart from updating my build, my dev environment. Big changes on the dev environment. So I have updated to the latest Kickstart, which I was way behind. AC, hello. So now we've got stuff like there's like fancy new icons here. I don't know if that makes any difference, but they are now there. I'm also experimenting with a new plugin which highlights the scopes. You see, you get the color bar to match those. I'm not sure whether I like it, but I'm kind of curious to know whether people find that more useful from like a streaming point of view. Is it useful to know what scope we're in by having like the colored bars? I'm kind of happy to be driven by the popular opinion on this. It's pretty easy for me to disable. It's not perfect. Like I would expect there to be a pink one here for the object scope, but like for the object constructor, but maybe it's just done on scope level. I don't know, but yeah, we'll try that. The other thing I have changed is I can now do leader KO to switch between the header and the source file. which is nice. And I can also lead a KV to automatically split to the opposite one. So that might make moving around a little bit easier. So it's nice just to like go between the header and that. But the other big news change is I've finally integrated DAP. So we now have debugging from directly within NeoVim. It's not perfect, but it sure beats having to like faff around with VS Code. So now we can now step, okay, and then we can see the registers, we can see the values, so we can go down here, like see the entities. It's got all the like the pretty printing and everything. It's like this is the transform, blah 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 blah. This view isn't perfect because this is pretty much just like the vanilla DAP UI. Like I don't know what this I don't know what the DAP console's for. Probably, and I don't really care for this GDB view. It needs a little bit of tweaking, but like I'm interested to give it a go and just see how it's done. Like I don't have all the hotkeys set up, so like I have to do DAP terminate to get out of it. But it'd be nice to basically. I think I might still run stuff from the other pane just because it's easy to see the logs and stuff. I don't know. Maybe we'll just try just pressing F and F5 and just seeing what happens today. But let's see how we go, because I was thinking about it, right? And like I use the min.gw build of GDB as the debugger input into VS Code's debugger abstraction. So it's like, if it was VS Code, like why wouldn't it work with the NeoVim DAP, the debugger something application protocol? So yeah, spent a bit of time messing around with that. I've not really had a chance. I've yet to write something I need to debug with it because I've not done any more work on it. So we'll see how useful it is when I actually need it. But for now, sorry, I can do lead it. So I don't know if you can see in the gutter now, I can set breakpoints, which is nice. So it's all kind of self-contained now. Well, yes. Well, so today's plan is to implement Bloom. So there's kind of, as with all things in software engineering, there's multiple approaches. There's multiple ways of doing these things. And I have chosen to go back to Learn OpenGL. Now, Learn OpenGL has, in the advanced lighting, has a Bloom implementation. And it goes through kind of how to do it. And you do the high pass, and then you blur it, and then you aggregate it back, and it's got all this great stuff. But I'm given to understand that this is kind of a bit shite. It's kind of like okay, but you know, you gotta have like multi-pass blurs and all this sort of stuff, and you end up with the sort of a lot of issues with like the blurring and stuff like that. So, but there's a secret guest articles, which I don't think I didn't really know about this until I found this through Google, but there's a guest articles with a load of extra stuff in it. And one of them is physically based Bloom, which is fun to say. And this has a sort of softer, more physically accurate Bloom way of doing it. So we're going to go and try and go through this and implement this today. I don't know if I can... I don't think I can minimize this. No, I'm not running my own debugger, it's just GDB. Ben, hello. Mystery, hello. Okay, so blah, 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 prerequisites, blah, 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 HDR rendering, which we've got, tone mapping, which we've got, gamma correction, blah, 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 all that good stuff. Bloom is cool. Agreed. Off to a solid start. It does have a link to this article, which is like Bloom disasters, which I think is like the overuse of Bloom, where literally everything bright just bleeds into this. Oblivion is like the poster child for like over Bloom. Like Halo 3, classic. Do you plan on fixing the things where lights end up lighting things around the corner? Potentially. So I've had a bit of a think about this. I might be able to assign like IDs to things, then have lights only affect certain IDs, which is basically forward clustering at that point, which I don't really want to do. So undecided. Two worlds, like Spyro. Anyway. So I want some dials, some levers, some knobs that we can kind of pull and twiddle to kind of dial in the effect that we want. Yeah, like kind of entity tagging, right? So like this light affects the. You could probably do with a bit mask, right? So you could give each. You could have each light could have like 4 bit masks or something, and you could give each entity like a byte ID, and then it could just basically affect some combination of those. I don't know. I've not really thought it through, but I think that's definitely a possibility. Bloom done right. That's what we want. Like, we don't want the shit bloom. We want the good bloom. Don't want the shit one. So I'm not using a physically based render. I'm basically using Bloom Phong, but I don't think that matters for this. At least I really, really hope not. So basically what you do is you take your scene with the lighting applied, right, into the HDR color buffer. So this is the output of the lighting pass of our deferred renderer, right? So we've filled our big fat G buffer, and then we've done the lighting calculations. So for this, you do not use a color threshold. What you do is you basically downsample it and then upsample it again using some clever sampling patterns, and that naturally blurs things. And the way the sampling does, it naturally favors the brighter parts of the image, and then you basically just like smack them together at the end. So mimic how just we render a mixture with HDR, but then you mix them together. Okay, so it may seem counterintuitive to bloom the entire scene and not the bright objects, but since we're composing a bloom effect for HDR pipeline, not a problem, mate. Not a problem. Everything with a good bloom effect, blah, 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 blah. By reading this article, blah, blah, blah. Sure, extra reading if you're interested. I'm like kind of happy to just go off this article, but there's some extra gubbins in there. I think this is the key part. The quality of the bloom is highly dependent on how you downsample, right? So we're basically going to construct our own mip-maps, right? Poorly designed filters lead to pulsating artifacts and temporal stability issues, and no one wants a temporal stability issue. But so this was made by a chap, or at least was presented by a chap called George Jimenez, and apologies if I butcher that. And it was used in Call of Duty Advanced Warfare. So it's like 2014, right? So this is still like a 12-year-old technique. Yes, sorry, I'm aware that forward clustering is slightly more involved in that, but I feel like it's kind of like the precursor to this, is where you start binning lights to what they affect, right, for optimizations. Motion blur, I don't know. I'm undecided if I'm going to do motion blur, because I know it's a bit, not everyone likes it, and I'm not sure if it really add anything to what we've got, so I'm undecided yet. Okay, so basically you run a shader which downsamples the HDR buffer containing per pixel color with light to shadows applied. The shaders run a fixed number of times to continue to produce a smaller image each time with half the resolution. Okay, so it's going to go... And then you run a small 3x3 filter kernel on each downsample image, which I think basically helps with the blurring, question mark. And then you progressively upsample them again until you get back to the original size. So you're going to go... and then... Finally, you mix it all together in a big pot and call it a day. So here it is. So our image is 1080p, right? 1920 by 1080. So we're going to downsample, and then blur and upsample. That is the plan. You can go smaller if you wish by having a texture F, but I'm probably going to... I'll try and make it configurable, but it might be compile time configurable rather than runtime configurable. I think the machinery of changing this at runtime might be quite heavy, and probably won't get us anything. But obviously, the more you do, the more computationally expensive it is. So I'm kind of hoping... My goal is to find some sort of happy medium where we've got some number of samples which we think runs reasonably performantly, and if you don't like it, you just disable the whole thing. We also do not need to worry about running the 3x3 filter kernel several times on each image, as the downsampling and upsampling result in a blur that closely resembles a Gaussian blur. So I think you just do the 3x3 kernel on this one? Question mark? Okay, here's where the secret sauce is, like the magic. Now that we have the algorithm in place, we just need to figure out which filter kernel to use. Sledgehammer Games do the work for us. They present a customly designed downsample kernel that performs 13 texture lookups around the current pixel and blends the values using a weighted average. So you do 13 taps, right? So this is the pattern that we filter. Sorry, this is the pattern that we sample in. So if this is the current texture that the fragment shader is running on, you sample these 13 and then you blend them with this. And apparently this is good. The above image deserves some explanation. Look at patterns divided to 5 color regions. The center pixel has 4 color rings on top of each other, as shown with text. The 4 red pixels contribute, so these contribute half, and then 0.125, and then those are all 0.125. I don't know. Anyway, this is how it works. I have added thorough documentation encouraging software development best practices to help you understand how the filtering works. See what their software engineering best practices are. I don't think the shader is too bad, right? So this is your fragment shader, right? And you're literally going to take your 13 samples, A through C, and they're all just slight deviations from X and Y, and then you just combine them as such. And then you basically just run that n times to give you your n samples. So your n bitmaps. And then the upsampling timer works in the opposite way, progressively blur and upsample. Yes, correctly, you're right. It's the blur is on the upsample. From the previous figure, using letters A to E, this is the float. So I think you do 9 taps on this. Yeah. Take 9 samples around the current texel, apply a weighted distribution by using a 3x3 tent filter, one of my favorites. Both the upsampling and downsampling shaders require vertex shader, blah, blah, blah. So, and then he has his software engineering best practices, which includes Pascal case for classes and two-phase construction, which, sure, we can deal with it. But basically, we're going to end up with some vector of things. I guess we better just start writing some code. I'm trying to think what the best way to start this is. Probably just to do one downsample and then I guess like put it in the debug renderer and see what it looks like. There's going to be a fair amount of like boilerplate for this. Okay. So now I can easily go between header and source file. So we're going to need to produce, so how many do they do? They do, is it 5? So you've got your full res one, which is the output from the light shader, and then we're going to do 1, 2, 3, 4, 5 down samples. So we're going to have 5 bloom bitmaps that we first need to produce. So I guess the first thing to do is produce the 5 downsample bitmaps. So let's do, so after the lightning pass, we're going to do auto execute bloom. I suspect some of this might be more efficient as a compute shader, but I'm going to do it as a fragment shader just because it's easier for my simple brain to cope with. I don't think you can use multiple buffers because they have to be different sizes, right? So, and I don't really want to worry about like clipping and scissoring and windowing and all that gubbins. I don't think we're that tight on GPU memory at the moment, so I'm probably happy just, and also each one is half the size, quarter of the size of the previous one, right? So let's do KO and let's do lighting pass. Auto renderer execute light. Also, I've not really done any programming with this new setup, so who knows what kind of oddities are going to be around. I've already got that one, isn't it? It's bloom, isn't it? Just really like that lighting pass. So this is going to be execute lighting pass, then execute. Basically done it. I think it is bilinear, yeah. Remember to add bilinear minification filters for this texture, and this is on the downsample. So I guess I need to, is that something I need to add on my sampler object then? And I need to edge clamp as well. So there's a few things I need there. So I guess I'm gonna need a custom sampler for this. So I don't know what I've got in my sampler. I've got linear map, linear nearest, and then clamp. So I've got clamp to edge for the wrap mode. So does that mean I'm going to need a new filter type? Is there a bilinear one? Looks like there's only linear, nearest map, etc. So I don't know if there's a... Yeah, in fact, from Kronos site. This discussion has refrained from using the common filtering terms bilinear and trilinear. This is for a good reason. These terms are often misunderstood and do not carry over to all the texture types. So I think linear, probably fine. Okay, so we got that. So we're going to use linear and we're going to use clamp to edge, which I think is what they said. So that's fine. So I guess let's do renderer. So we're going to need... Am I going to... What's the best way of doing this? Do I want render targets for each one? Or do I want just textures? I probably just want textures. Is that right? You just write out to... No, I'm going to need render targets, aren't I? So I'm going to have to bind each one, because each render target has inherently a texture handle that I can write to and a frame buffer. So I think then I want stirred vector. Wait a minute, I can go... I only need one. I don't need to maintain an upsample and a downsample one, right? Because I'll just fill them with a downsample and then I'll just reset them on the upsample. Right. Something like that. Yeah. Okay, so we'll stick that in there. I'm gonna need I will need two programs though. So let's do the first one first. That's gonna be the program Bloom downsample program. All right. That's what I'm gonna need there. So if we go up to the yeah, program. Okay, so hang on. Right. Okay, so after the chromatic aberration one, we're gonna create the. So this is going to be the C2T underscore Bloom downsample. And this is going to be downsample vert CFN. Yeah, nice. Bloom downsample. Blah, 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 blah. Nah, mate. I accidentally overwrite the same thing. I'd much rather painfully go through and figure out what letter I want to replace to, and then just put in the Vim motion to edit to there. Okay, then after this chromatic aberration, so this is going to be Bloom MIPS. Okay, so I guess at the bottom of the constructor now we can probably work out what we want. So let's do static const expra bloom mip count equals 5u. Okay, that seems like a good place to start. And then let's do for const auto. Oh, no, constant. Not doing template. Oh, could we do template expansion? Is that really outrageous to do template for const expra auto I in stud views iota bloom? Oop. Mip. Is that, do we hate that? Okay, fine, whatever. For auto I equals 0 I is less than bloom mip count. Twangd really doesn't like the template expansion. Okay, fine. Boomer loop if I have to. The vector is going to hold the MIP chain, right? So the vector is going to hold these 5 things here. So we'll already have this, and then we will store the OpenGL gubbins that represents each of these downscaled ones. But it's less functional. It means my loop iterator can't be const expra. I mean, it only compiled technically to the same thing if the loop gets unrolled. Otherwise, you'll get a separate line for each of them, and this will technically compile with jumps. But like, I think we're getting a little bit facetious now. Okay, let's do. How do I generate a? How does one? I can't remember how any of my own. I cannot remember how any of my own code works. Create render targets. I might just steal this. Stick this here, and then we can do bloom mips dot pushback. Okay, so this and so we're going to do const auto scale equals static cast float I plus 1 U times 0.5F, right? And then I can do scale. I think that's right. So we'll have 0.5, then 0.25, then 0.0125, then whatever the others are. And then this will be stud format mip I. Maths not mathsing. Do I need to square it? Yes, I need to. Yes, you're right. So it needs to be stud pow 0.5 times that. Is that right? No, I don't think we need to squirt it because that will make it bigger. Okay, I think that should fill those out nicely. Half is the square root. I guess, yeah. Yes, sorry, you're right. No, but that's only if it's the power, right? Whereas I'm doing 0.5. Have I gotten this the wrong way? Yeah, that's right. You're right. I have. No, I want that, don't I? I want to do 0.5 raised to the power of 1, which would be 0.5, and then I want 0.5 squared. Yeah, I think. It's been so long since A-level further maths. Yeah, this does gamma correction and sRGB, and then does everything in linear space for HDR. Yeah, I think that's right. Find out soon. Bit shift would suffice. Yes, I tend to avoid doing bit twiddling for maths because I actually find it harder to understand, as in like to read. Whereas I feel like a scale factor is, although actually in this particular example, because I'm even struggling to conceptualize the maths, maybe bit shifting would be easier. So you're saying would also get you the same. Nope, wrong way. Yeah, so I don't care about the optimization. I care about readability. I don't know which is more readable, that or this and scale. I'm going to leave it as scale, I think, because I think that is more intuitive to read, but I'm happy to be wrong. Okay, so we filled out that, and then now I need to copy assets, shaders. I guess any of the post-processing ones will be fine because they're all basically the same vertex shader. So let's do tone map vert into assets, shaders, bloom, downsample.vert. That's all we need, right? Because again, all it's doing is just sampling a big texture. That should be fine. And then let's do copy assets, shaders. I guess we can do tone mapping fragment shader again. Asset shaders, bloom downsample.frag. Okay. Okay, so don't need that. Don't need that. I don't need to bring in anything, right? All I'm going to need is the input texture. I don't even need that as a sampler, right? This is all I need is these two, right? Because I'm not reading from any additional textures. I'm just sampling from. Wait a minute, hang on. No, I still need to pass in the thing I'm sampling, don't I? Because it won't already be in that texture. Yeah, sorry. I'm stupid. Let's go back a bit. I do need that. DI. I'm trying to get better with some of my Vim bindings. Can I do that? Yeah. Yeah. Clean it. Delete everything between the braces. Nice. Bear in mind, that code doesn't matter how slow that code is, right? Because it's happening in the constructor of the renderer, which would just be done once at the beginning. Fuzzy, hello. Okay, so we now have the infrastructure set up, which does this bit here. So we have this, so we just need to write this here, right? And obviously I've not wired any of this in to actually execute yet, but that's where we're at. So let's do So I've got to make sure I get this right. So I've got the source. It's like the difference between empty and size is greater than 0 in C++, right? Which you should always use empty because it's, well, prior to C++ 11, I think size wasn't guaranteed to be constant, so it was always more performant to use empty. But I would argue that empty is semantically clearer than count is greater than size is greater than 0 because it's much more explicit on what you're trying to do. So I would always say that any in that case is better. Okay. So we got our main. So I need the source resolution. So that's going to be another thing and such, isn't it? So that's going to be layout. I don't know if I can have a vec2. So it wants a vec2, but I don't think I've no way of representing a vec2 in C++. I guess I'll just figure that out when I get to it. Source resolution. I suspect I just need to have an overload in my program which takes 2 floats and then it just knows to bundle them in. So they have vec2 source texel size equals 1.0f over u source. Oh, I don't have any of the autocomplete anymore. That's sad. Don't you just pass a struct with 2 floats in? Possibly. I need to look at my abstraction, right? Float. It's worth create a small program so you can include other files instead of having to copy. I've not needed, if you're talking about me for this project, I've not needed that yet, so I don't think it's probably worth the effort, but like that's not to say it wouldn't scale to the point where I would need that at some point in the future. Because we need to calculate texel size because we need to do this 13 tap sampling pattern and blend them all together to give the best results. It's not just a case of downsizing it. We need to downsize according to this sort of bilinear fetch pattern. Because that's what the internet told me to do, by the way. Like, I've not read the original SIGGRAPH paper. I am tempted to just... I don't normally do this, but it's an awful lot of typing and an awful lot of mistakes that I'm obviously going to make. Text quad in UVG. And then that is %s source texture u source input texture. I think that's right. I mean, I hope it's right because I should have just copied it off the internet. Yeah, like I was going to make so many typos. Oh, interesting. So yeah, so I was like, what the hell is a downsample? But yeah, that's just his out parameter. So we can just take this again. I am almost certainly going to like make an absolute pig zero of that. Let's do %s downsample out color. So I called it out color. Okay, fine. So that should. What we should probably do is just wire this up and just see if it runs first. I'm having fun. I'm having the time of my life, mate. So let's... I guess let's just check it. Oh, I can do FNF5 now. Ooh. Be interested if this doesn't work. I'll be interested to see how this like materializes itself running through the debugger, because I can't see the log output. I mean, it built. Okay. Oh wait, what? Oh, muscle memory. That is strong muscle memory. That after I finished closing, I instinctively went one pane to the left in Tmux because that's what I've done every time till now, forgetting that I was in the current window. Yeah, we could. That is a good point. Let's just be like, no. Oh my goodness, muscle memory. Right, this is. Oh, I have to be in a CPP file in order to run the debugger. Good to know. We could just tail the logs, because I think the logs get written to a file in the other window, so we don't lose them. That doesn't look like it's doing anything, does it? Yeah, but like it still has to create the program, right? It still has to create the program first, which means it has to go through the GL compilation and the linking. How do I feel that AI can reverse almost any binary now? It absolutely cannot reverse engineer almost any binary now. Like that is it. It's probably getting better, but there's still stuff out there it can't do. Why is that not exploding in like a horrific... Oh, to my FNF5, I bet it doesn't build it. I bet it only runs it. So I bet I'm running the last like valid build. Yeah, okay, fine. I need to fix that. FNF5 needs to run the build first. Good to know. So this should go... Pop goes the weasel. Yeah, okay, fine. So what does this now look like? It's fine. I'll just vibe code some more like Lua config. Okay, it just dies. Good to know. Okay, fine. So we might still be running it the old way for now, I think, and then just move. Maybe we'll just use the debugger when we need it, which is basically how we were using VS Code. You know, just bust it out when we need it. Assignment of incompatible types. Good to know. Bloom down to front shader 34. Didn't we have this issue before where I was like, just change that to a 3 and it absolutely like did not like it? Yeah, I'm sure we can figure it out. I mean, accepted that. What I might do is add another tab here, which just shows the bloom bitmaps, because otherwise this is going to get quite busy. But at least it might be useful just to see if it is like indeed blurring. Yeah, that's a good point. Well, let's just leave it at that for now and we'll see what happens. So yeah, we need to make sure that we want to see this blooming. Okay. So let's go back to the renderer and let's start wiring this up. So we want to go to... So I think we want to do... Oh, actually, hang on. Nope, never mind. So for const auto... mip in bloom mips, and then we want to do auto source width equals, what's the input to this? It's going to be the light pass RT dot frame buffer dot width. All right, bear with me. I have a cunning plan. So what if we do this, right? And then at the end of the loop, we update it with the source height and width of the current one. And that should means it's always loaded, because you need to pass in the width and the height of the thing that you've of the previous step, right? So we should be able to then get this set for the next iteration. Oh yeah, the program binding nonsense in a second. We've been heavily using reflection in this. I have used contracts in another project, but I've yet to find a good point where I want to introduce contracts into this. Like there are loads of good use cases for contracts within this project. I've yet to find a point live where I kind of want to stop and do it, if that makes sense, because we've been doing other stuff. Also say these vector, maybe like one thing at a time. So this needs to be mip, right? So that will get those ready, and then now we need to do all this nonsense here. So I want so first thing we're going to do is we're gonna bind our MIP and clear it, and we're gonna want to clear it on both ways, aren't we? So that'll clear the current MIP, and then I'm going to want to auto bind the program, but I'm going to want to only bind it once, right? I don't want to keep binding it. I don't know if OpenGL is clever enough to, if you issue a bind call to a program that's already bound, if it just makes it a no-op. But, and then eventually this will all be scoped, right? So this will be something like this for the downsample and upsample. But let's do bloom downsample program. Bind, clear, and then set uniform. So this is going to be the, again, I'm going to need auto source handle equals light pass RT dot minus handle that, and then we're going to do source handle equals mip dot curve like that, and then this will set the uniform for source handle, and then I'm going to need to do something like it's something like make tuple source make tuple source width source height. Oh, we'll just blindly just unbind and bind it. Great, good to know. Okay, so now in set uniforms we don't have an overload for a tuple of floats, which we can add. So let's say we are here. The tuple of float and float. And then take that and into program and actually tuple. That GL header's in the wrong place, but whatevs, fix in a minute. Oh man, similar numbers on Twitch and YouTube this evening, which is great for me. Because at some point we might want to do a vec3, and I'd rather it be consistent. So the question was why a tuple and not a pair? It means that if I want to have 3 in the future, then at least it's consistent with all of them. That's kind of my view of it. So we'll just do that, and then I should be able to do GL program uniform. Oh, I better don't have it. Better don't have it. Which one does the vec2? I want 2FV. I want the one where I can pass in the individual values rather than having a pointer to it, though. Will 2UI... Will this bind to... I suppose that's an int, isn't it? Is there a 2U... Is there 2F... I don't want the V. Is there a 2... 2F? Will that bind to a vec2? I think it will. I got a 1F and a 3F, so it seems like it'd be rude to not have a 2F. GL program uniform 2F. Handle. Yes, I just borrowed your color into there. Yes. 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 Okay, nice. That works quite nicely, I think. Well done, me. Until it doesn't work. Okay, so that should now plug those two in, and then we just need to execute it. There's no buffers to... We just need to bind the vertex buffer so it has access to the this full screen quad, and then I think we just issue this. I think that's all we need. Just check I'm not missing. I have a horrible habit of copying these random GL commands around and not updating them for the specific context I'm in. So that should execute those 5 passes and downsample them. Oh, man, it's gonna be easier than I thought. We could be done by 10. Early night, extra beers. No, the post-processing command buffer is built once and has the exact command in to render a full screen quad, and all the post-processing steps reuse that. TFE is not supported in Intel graphics cards. I mean, don't know what to tell you. To sell your soul to NVIDIA so you can have the 2FV functionality. Setting uniform on unbound program. How dare you? Yep. It's not wrong. It's not wrong. But we all make mistakes, right? We all make mistakes. No one's perfect. Right, well, that sure did sure ran. I'm gonna go to my least favorite file now. And do render targets. So let's do mark A. Go down, right. Yank A P. Nope, that's not how. What? Yeah, that's what I thought. Yank A P. What have I done? Yeah, fine. Begin bloom MIPS. Reuse those from above, and then. And some people stream. It's just, there's no secrets here. So for const auto mip in the bloomin' mips. This file needs to be burnt to the ground, and the earth in which it has been burnt salted so nothing ever grows again. It is awful. So let's do texture mip. That might be good enough. Yeah, exactly. No one should ever have to see that code. It just needs breaking down into functions. All it really needs doing is just breaking down into some functions and having a bit of the boilerplate abstracted away into some helper functions. Like, it's probably a couple of hours worth of work. Yeah, nailed it. Crushed it there. What am I done? Am I doing something wrong here, or? Change objects it is referring to. Help. I don't understand what you mean. Yes, I see what you mean. So that should be mip dot. Oh, where's the autocomplete gone? That's how am I supposed to write anything? Oh, thank you. It's just a bit slow. I'm not convinced that's gonna help. Is the aspect ratio wrong as well? I suppose the aspect ratio would always be the same, right? Because they're just downsampling halving each side. Remind me how it works for the other one. But yeah, you might be right. Oh, I hate the way that's the default as well. That needs to change. Can I? This always needs to be the default. I bet it's the order they're rendered in. Let's just. All right. Well, we're going to be spending some time fixing this now. Which means I've now lost this. No, because width here is the width of the square that I want to draw, right? Just scaled by the aspect ratio. That's I want to render into this. I think this is right. Because I want, whether this should be height or not, I don't know, but I need all those squares to be rendered the same size. And then everything is, then I think Imgui just handles the scaling for you. I've not set a sampler as well. I just realized, don't I need to do the clamp to edge sampler as well? And the is that, where do I do that? Let's just fix that quick before I forget. Ah, so that's the sampler there. So what is that actually set to? Oh, it's already set to clamp to edge. That's fine. So that should work. So yeah, that's why they all render the same size. Okay, but I don't understand why it's just. Is it because I bet it's that weird Vec3 output thing. I'm a thinking. Right, let's do debug. Let's do bloom down sample. Let's do, we had issues with this before, right? Doesn't it set like the last one to transparent or something? What have I done wrong? Oh yeah. Get loads of those, mate. Everyone's a winner. Look, we all make mistakes. Gonna get that on a t-shirt. Oh, under my... Oh, God, I have to lose my citizenship for that. Oh, there you go. That looks scaly. It's certainly, like, you can see the color bleed there. I know, right? Get me out of this. Get me out of the country. Everything is very bright. It is. Look how bright everything is before the tone mapping. I think there's going to be quite a lot of bleed in this. Right, okay. So now we need to do the upscaling. Can you change the default window background color to something darker? What's this? This color? I cannot do that, I'm afraid. Like I'm very, and I'm sorry if you find it difficult to read, but like I'm very funny about my color scheme, and I really like this one, and everything I have is this color scheme, which it sounds really lame, and I'm sorry. Assets, shaders, bloom, downsample will become assets. We could just keep the same. We could just use the same one, but I might as well do this. Bloom. Upsample.vert. Oh, not the. Oh. Oh, so you don't have a blinding white screen. Default window background something darker. Is that what you're talking about? How do I change that? I'm going to change default window color, because that's before OpenGL's kind of kicked in, I guess. Whoa, this looks this is not a simple answer, this. The system paints the background from window, given the opportunity to do by sending the WM erased back end message when the application calls begin paint. If an application does not process this message, it passes when the system erases the background with the pattern on the background brush specified by the window class. An application can process this message even though class background brush is defined. To use this to change the window background color. So use the when background to get the DC and paint the background. I might have to look into that separately because I really want to try. Unfortunately, you might have to suck up the blinding light for today, which I appreciate is not a great answer. But I really, for the amount of time I have today, I really want to try and get the bloom done. That might be something I kind of tweak off stream, or we do at the beginning of another stream. But yeah, Windows API is like, no. But yeah, I see what you mean now. So you mean change my precious color scheme. I was like, how dare you? Copy source. Nope. That's where someone clips that. It's like this tosser won't change his colors to help people watch his stream. Shaders, bloom, downsample frag to assets, shaders, bloom downsample frag. Okay. Upscale vert should be the same as before. Upscale frag should be all this gubbins, which will change. Right, let's go and wire up all this horror now. So now we're going to have upscale, upsackle. We're going to upsackle that. Ooh. What have I done? Help. What mode am I in? Why is moving up and down just changing these characters? What? Ass program indeed. Ass program indeed. I can't escape. I'm stuck. What mode am I in? What have I done? I can't change to another window. Okay, right. Is the font size alright? I feel like it's a bit small. What is going on here? No, I don't think I have caps lock on. What is... Yeah, I think we're going to have to kill this and start again. That was weird, right? Like, it's not just me. Also, if I called it down upscale and downsample, so CFN up. Right, there you go. Well, I've swapped escape and caps lock, right? So it's very unlikely I'm going to accidentally hit caps lock because it's really far away now. Okay, so we're going to want to do this. And then we're going to reset these. Actually, no, that's... let's write the bloody program first. Okay, so back to their code. So it's pretty much the same as before, but they also have so they don't have a source resolution, but they do have a float filter radius, which I guess we're gonna want. I'll have one of those. So hang on, nope. DI close brace, yeah. Okay. Put X equals U filter radius. Oop. Because I'm a terrible typist. Right. So %s source texture becomes U input texture, and then %s text called becomes in UV. Make sure that's -G so you get all the ones on the end. Bish bash bosh. And then what's their U sample? Is that their output? Okay, fine. So what we're going to do is we're going to do Vex3 color, and then we're going to do up sample. Yeah, I know, I've seen it. And then we're going to do out color equals vec for color 1.0 f. Sure, let's keep it inconsistent. Okay, right. So this should be all we need now to run back up. Binding JK, as in pressing them both together to escape. I think I might be against it, but I don't know why. Okay, so let's see if that blends. I don't think we've done anything other than just scope that. So this should continue to run. It should check and build that new program. Nope. What have I... Whoa. Oh, because I went to do /G and I did .G instead, like an absolute fool. Like an absolute cretin. Oh, really just... Where does the filter radius even come? Oh, it's just there. Okay. Oh, because it's the... I guess it's how much you blur over. Okay, so that blends. Okay, so now I'm going to do this. And I'm going to... Yeah, it's not... OpenGL hasn't started running at that point because I do clear it to black, so... Okay, so let's do the up sample. Okay, and I'm going to go through the... So I want stood views reverse. And technically, width, height, and handle should already point to the last one we processed. But you're right, I might want to do these as a vector because I'm never going to be able to get the final one out. So I don't really want like some miserable kludge code in there. Because this is already set, so I can work my way back to get to these, but it's getting this one. No, it doesn't matter because it's the source, isn't it? So I think that might be... Wait. This is a separate pass, isn't it? These upsample to here, and then I need to do the final upsample and mix it in with here. So this final one, so I think that's right, isn't it? I'm going to do from here to here to here to here to here. Okay. And then... Yeah, and then I can basically just apply this sample. I wonder if that's how they've done it. Let's have a look. I've got their... where's their code? I was just wondering if I can just combine that last upsample with the final mixing. So they've got the final bloom. Oh, they just have it already calculated and mix it in. I guess I could just manually execute it. It's not going to be the end of the world, is it? Hang on, have I got this? I need to drop the first one, right? Sorry, after the reverse, drop the first one. Because I am... Where's my diagram? If I... Yeah, so... No, MIP 0 is this one. But MIP 0, 1, 2, 3, 4... Is that right? Yeah. Have I got too many MIPs? No, I've got 5. Yeah, so 0, 1, 2, 3, and 4. So if I reverse, I'll start at this one, but I want to upscale using the previous thing. So I actually need to start here and then use the previous data, right? So I want to do diffuse drop 1, right? So this will then do this here, because I'm writing into this one. So this will write into here using this data, 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 at which point I then need to issue probably one manual one afterwards to do... No, because there's no point storing this data. There's no point having a second full res one, right? I might as well just have a pass which takes both of these two inputs, does this upsampling manually, and then blend it in. Right? Like, there's literally no point in... There's no point in storing that data again just to blend it when I can calculate it. Yeah, okay, fine. I think there's some extra uniforms I need here, right? So I've got... what do they recommend as a... So they've got... What's this rando filter radius? What do they recommend as a filter? Do they have a recommendation for a value for this? Bloom filter radius, not cool. Great, love it. So let's do static constant auto. This needs to go into the... This needs eventually go into the scene settings and then be controllable via the debug renderer, the debug UI level, but let's just get it working first. Radius equals 0.005f. Okay, and then this goes... here. Hang on, ICRIB? Nope, not that one. Whatever. Bloom filter radius. Okie dokie. Alright, so that should now up it. Which will fill those in, and then now we need one last hurrah mix, which is going to be copy downsample vert to bloom mix vert, and then copy frag to bloom mix dot frag. Okay. Did I copy? I bet I copied the wrong one. I bet I actually copy. Life is so hard. Shaders. Bloom. Upsample frag to assets. Shaders. Bloom mix frag. That's got the logic in it already. Okay, so let's go here and go mix, upsample yank 272G. I feel like this could be sort of auto-genned at some point, but hey, what are you going to do? Up samples, so CFE mix. Okay. And then, right, down we go here. So now we're going to need to do... auto bind CFE mix. Get rid of all this because const auto mip is gonna equal to blue mips dot front. Bind that. Typo. That's gonna need to be the upsample program. Made that mistake already. Hang on, what am I doing? Yeah, just seen it. And then this will become CF mix, which is going to take the... Well, we probably need to write it first, don't we? Upsample program. Yeah. What else have I missed? Yes, I put auto for everything because I think it keeps it consistent with nice indenting. But that's personal preference. You absolutely do not have to do that. Apparently it winds some people up, so I don't know if that's more or less reason to do it, but it's just my personal style. Okay, right, let's go to the mix. So we're gonna have here, we're gonna need two inputs, right? So we're gonna want the U MIP and the U light texture, right? Don't know how to manage that. And then I think this is going to need another uniform, which is like U mix amount. So we're going to take in the MIP texture that we generated, and we're going to take in the light pass texture. And then we're going to calculate the final MIP level, the final upscale, and then we're going to blend them together. GL clearing MIP FB seems wrong. Yeah, it might be wrong. I just copied that code. We need to go and have a look at it. It's probably wrong. That's a good point. Okay, so we're going to do the same stuff again, and then we're going to do... I'm going to call this final MIP color. It's the final MIP color. Okay, right. So we calculate that. Do I need another uniform for that? I still need the U filter radius, don't I? The C++ work with Raylib. Yes, Raylib is a C API, which is one of the strong selling points of C++ originally, is it's got excellent C interoperability. Okay, so we do all that, and then we're going to do out color equal... So hang on, I'm going to do vec3 light pass color equals texture U. I need to change all those input textures, don't I? Light pass texture in UV dot RGB, right? And then what we're going to do is we're going to do mix light pass color. I'm hoping I got these the right around. Final MIP color U what do I call it? Mix amount? Mix amount. U mix amount. Codex is cool. All those agentic tools are pretty cool. if it helps you be more productive and get work done and add value, then sure, that's great. It's like, I still think there's value in learning to type out code and really getting to grips with how the stuff works under the hood. And I think AI will kind of remove your your ability to do that. But I'm discussed AI a lot, and I really there's loads of shorts on it, in my opinion. So I'll start from here, going to here, mixing this amount. Is that, yeah, okay, fine. I think is that right? Okay, so let's do, and I just need to change this U input texture. So %s U input texture to be U, was it final? No, it's just U MIP texture, wasn't it? U MIP texture. Okay, right. So then we're now going back to the renderer and we can start wiring this in. So, correct. I do not want to clear it. And then for the uniforms, I want to do set uniforms. So this needs to be source hand. No, I want the final MIP one. So that'd be MIP dot color texture handle. Then I want light pass RT color texture handle. Then I want bloom mix amount, which I've obviously not specified yet, and then I want to pass in the bloom filter radius. And then where do I declare this? Let's do bloom mix amount. I think that's actually in the article. He says, oh, they say, sorry, right at the beginning, how much you should mix it. With a strong bias towards the HD color buffer. So about 0.04. So does that mean I want... We render mix between using a linear interpolation with a strong bias. So what do they do in their actual code? They use bloom strength. So they hard code this to 0.04 and they mix it and they do HDR color and bloom color 0.04. So that should be 0.04. Okay, let's see if this works. See if we bloom. With none of the dials light up, so we can't tweak anything. Like, it's largely just like taking someone else's OpenGL code and just wiring it into our infrastructure this, so I'm hoping it's not going to be too outrageous. I don't think that's worked. Oh, okay. Is it? Are we blooming? I feel like we're not blooming. Right. I could be wrong, but I would expect more. Oh, there's something wrong there. Okay, let's work our way back through this. So we bind each MIP, we clear them, which is oh, the upsample's correct. Probably not. We probably need to do those as well. So let's. Oh, you can't. Oh, I can't log the upsamples because I reuse the same buffers, don't I? So that's that. Hang on, let's do this. So we go for each MIP in our thing, going from the smallest to largest. We bind it, we clear it, we run the program. Okay, and then we update the source and width for the next one. So on the next tick round, on the next go round, we effectively have the previous width and height. Okay. For here, we go from back to front, ignoring the first one, because this is already set to the width and heights of the final one that we produced. Okay. We clear the MIP. And then we sample from the previous one. And then we update for the next tick round our current one. I'm going to get rid of this for a second, because I want to see if our upscaling is working, because we draw the same buffers at the end, we should in theory see, I suspect those are, I suspect we will see the same thing before they're flickering, so we are not, there's a problem somewhere. Are we clearing the upsamples early? I don't know. I don't know. This feels wrong. Oh no, it is. I mean, they are absolutely blinding white. Can I just stop this flickering for a second? Yeah, this is definitely wrong. So the upsampling is indeed not upsampling. So why is that? So we bind the upsample program, we set the correct uniforms, and then we've issued the draw command. Probably not. So let me just check. We have an input texture and a filter radius. These will come through normally. We have an out color for. Well, the downsampling seemed to work, right? So if we do. If we just comment out this, right? I'm checking I've not broken something else, but that seemed to fill out the downsamples quite nicely. But is it still downsampling again in the upsampler? I mean, it is separate code. We can go and double check it. Ooh, just falling through the floor. So yeah, this is definitely, like, it's pretty bright. Excuse me. I don't know if I can just make this a little bit less, like, outrageously bright. Some of these are very bright from left over from testing. You see these ones on the right flicker, but I think that's correct, just given the scale of the image. So, but remember they were all doing that the way across, so it does imply. I guess that. I think this is wrong. Because if I sorry, I know my fonts is in the way, but like if you upsample this, right, then you're just going to get another blank image. And if you upsample it, like, I know you lose information, but like this blank image in the bottom right, upscaled, is going to give you more blank images, which is then going to flicker like this does, right? Should we not be scaling the buffers then? I don't know. Let's go up to where we construct all this horror, and let's do. and do bloom mips dot back dot fb dot width. Let's just see what we've got. Well, they need to get smaller, right? Yeah, got that in the end. Yeah, I was curious to see what this outputs. Because it feels like we're maybe losing too much information. I don't know, unless this is right, but this just feels... So what was their article? I think that's right. 960 to 480 to 240 to 120 to 60 and then 33, 67. Okay, so that's fine. What am I doing wrong? Hang on, what's this? So they have A, B, C, D, E, right? So when they're upsampling, E stays the same. And then you plus D is D plus the blur of E B4. Yeah, I mean, the downsample is supposed to zoom in. I think so, because they're smaller images being stretched over the same size, right? Oh, do I need to change the viewport? Where do I do the SAO half pass? Yeah, I bet that's it. So let's do. You're right. They should all look. You should be able to see the whole scene in each one. There's a good point there. Okay, so let's try. For each one, then I guess we're going to do this, and then we're going to do MIP. Okay, and then obviously we'll need to change this back afterwards before we do everything else. I'm just going to... Let's just do light pass RT. Light pass RT. No, wait, is that right? I'm going to set it for the one I'm rendering, but I have the information from the previous one to downsample it. Yes. 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 Feeling confident. There we go. There we go. Oh, it looks much better. You can actually see where the bloom's going to kick in now, which is quite nice. This scene is so bright. Obviously, you can get tone maps, that's fine. Okay, right, let's go do the upsampling now, and then let's just see if we can see what those look like in the thing and such. So I'm going to want to do viewport, then after the clear, stick that into there. So good I viewported it twice. Okay, let's see what this looks like. Okay. Sure. Sure. It's certainly upscaled it. I think that is upscaled. It's definitely more pixelated. You probably can't see because my big bald dome's in the way, but it's definitely, if I look really close, I can convince myself that this is high resolution. Right, so this will just work now. And then we just need to, we might as well set this right where we actually want it. So we're gonna, hang on, I've gotta, we're gonna set this here. Oh, also, what am I writing this to? What am I writing this to? I'm going to need a final render target to accumulate these, aren't I? No, I can't read and write to LightPath at the same time, right? It's not a compute shader. Or can I? Can I? Can this be LightPath buffer.rt dot Facebook dot bind? Can I do that? So give it a churn, give it a whirl. I didn't know if you could read and write from the same one at the same time. You can, but we'll be funky. Let's give it a go. Otherwise, I'll just slap in another render target. What's another render target? So I do need another render target. It has made no difference. So yeah, I don't think it likes that. Definitely need those. Also, what do I then, what do I take the luminance from then? Do I take it from the bloomed scene or the non-bloomed scene? Because this reads from the LightPath render texture, right? But if there's more bloom, the scene could be brighter. So I presume I'm going to change this to that. Thoughts? Feelings? So I want a bloom MIPS, then I want a final render target bloom RT. So this is what the final thing is going to go into, right? Okay, so then let's do MIPS, and so this is going to be bloom RT. Ooh. Create render targets. All this useful. This is going to be bloom. Okay, and then so now we've got the bloom RT. We can go down to the bloom path. Oh god, having all these toggleables is going to be an absolute nightmare. Right, so then we're going to do. Also, some of these dials might just be wrong. Oh yeah, RT is just render target, sorry. Okay, so then I'm going to bind that. So this final one we're going to do, let's bring all this together now. Light pass, and this is going to be bloom RT. So this is going to take the MIP, the final MIP, and the light pass data and the other inputs and blend them all together in glorious cacophony of blurry light. Maybe I don't know. That's why I get something working first. So then I reckon here we're gonna do bloom RT. So where else is the light pass RT used? So that should be bloom. And then execute average luminant pass. So that's going to be that and that. Keep that the same. And then execute tone mapping pass. I'm going to want to tone map the bloom one now, right? That's effectively taken over. Let's replace it. Nailed it. Yeah, it's atmospheric. I suppose we could just be like, make it. Okay, right. What's going on then? I feel like the bloom mix program is probably not working correctly. So let's try. Just try that. Just check it's all wired up. Oh, I'm partial to COD, I must admit. I feel like this isn't doing much. Is from scratch as much as possible. I will definitely be using a third-party physics engine because I just do not have the time or the skill to build that. But other than that, all the rendering code, all the windowing code, all the event handling code, the coroutine-based job scheduling code, all that, the reflection-based whatever serialization code is all hand rolled. Okay, why is this not doing what I want it to do? So I've got the mix. These are definitely going in here, right? Yeah, that's fair enough. Yeah, and you could argue that ImGUI, ASM, and G-tests aren't really part of the final shipped binary either. So it's really just going to be Jolt as the thing that we ship. Why is my program not programming? Like, do we bind it? Probably not. Right, so let's. I can use my new fancy folding code to get rid of all this. I bind to the Bloom Mix program, and then I don't clear it, but I don't know if that's. I don't know how important that actually is. But we could clear that, set the viewport, set the uniforms, all right, which don't actually matter because we're just outputting red, and then we execute it. I guess the luminance would then be the. Curiouser and Curiouser. Why is that not doing anything? Oh, interesting. Okay. So that's the red color, which is then applied the SSAO to. Interesting. Okay, let's go back to mix. Undo that. Bish, bash, and bosh. Okay. I feel like it's still not blooming. I think not being able to use RenderDoc is a massive pain, but since I built out some of our own tooling, it's not been too unpalatable. So yeah, kind of okay. Turn up the light on the bucket thing. Do you mean this? Or on this? The generator bucket thing. I feel like the mixer. You can't use RenderDoc with binders textures on OpenGL. It's not supported because it's one of those weird things where it's technically an extension, although it's an extension everyone implements. So RenderDoc doesn't really support extensions. Right. Okay. So there's a couple of things here. Either the mix amount is wrong, right, which could very well be the case. So let's crank this up to like Oblivion levels, right? Let's do like a 50-50 mix. Alright, we want. I feel like it's like misty now. I don't know how to describe it. It looks. It's definitely. It's definitely not right. What have they done? Is mix definitely what I want? Bloom new. You take the bloom color and HDR color, and then you just mix them based on the strength. I don't. Yes, it is very bokeh-esque, but it's not quite what I want. I could wire this up into a handle so I can start playing around with it. Try to go into it for the mix. Well, I want the opacity to always be 1. I don't want to risk that, so I don't really see what the difference would be. And in their one they just mix the Vec 3. Yeah, that's a good point. We could just do this, right? And just see if we get the final out. Obviously, this would have been tone. I don't know if is it the tone mapping? Is it kind of dulling the? We might have a size mismatch somewhere. I don't know. There's quite a lot that could be wrong with this. I think we're close. Like we're very close. I really like to kind of get this knocked on the head today. That is blurry, but I feel like nothing's really bleeding out. Like look at this really sharp line up here. Can we turn the other the blur radius? Yes, we can. I just want to see. Is it nothing to do with like? Just want to see. It's got nothing to do with the tone mapping. Yeah, we could try and make it blur a bit harder. Just. Negative number. We could like 10x that. It's very close. Yeah, I just... Is everything just too bright? Ah, you see, is the scene just too bright? Because that looks kind of good, right? Let's try going back to the 50-50 mix and switching all those other lights off. They could just be too strong, and maybe everything is just like blown out. And because of this technique, maybe you don't get like the really high peaks like you do in just the high pass one. Right, my scene could just be shit. I will need to wire up those other bits as well, so we can like play around with this at runtime. Where's my... See that's glowing, right? That's definitely bleeding out. Oh, that's really nice with the adaptive, like, luminance. That's really cool. I think the ambient light's almost off. The ambient light is off. There is no ambient light. So you could raise that up a bit. Give it a little bit more of a punch. Can I make the fog a less silly colour now? How dare you? Just everything still feels a little bit blurry. It's probably because it's mixing too much. There's a light around here. So what if we make this like much more intense and like a red color? I don't want it to bleed too far down, which unfortunately it will do. What if we really like knock the attenuation quite down quite a lot, make this a lot more scoped like that? I think this is kind of working. I think it's just so hard to because I just don't think my scene is set up particularly well because there's quite a bright light in here as well. But that is pretty cool. Is it applying it before AO? Maybe mixing it after AO. Maybe. I think one thing we need to do though is let's whack this right back down to the tiny. Let's go back to the suggested values. It might be that we just need to spend like part of a stream just making a better representative scene. Yeah, I think I've just got tiny room, big light. So this, yeah, do I get any of the blur from this light? Not really. So let's delete that. Delete that. There's a light in here as well, so let's tone that right down as well. Nope, sorry, wrong. Oh, so bloody fans in the way. Right. Oh, that's really bright as well. Let's knock that right down. Someone doesn't like my fog color. All right, and then delete that. Okay. Yeah, okay, I think we're... It's not that blurry. We might need to tweak it a little bit. The other one looked much better. I think I need to wire that up into a... like a controllable thing. I can't see shit now. A light. I think we're like getting there, right? That's yeah, you can see this here. I think we need to tweak the amount. I'm gonna super quick and dirty wire this up. What's the quickest way of doing it? It's probably to move this to a member variable, which I'm not a big fan of, but I want to just it's so much typing to get it in the scene. I'm just going to shove it here. And then because debug render subclass is this, it should have access to this. And we can fix up later. Take on a little bit of tech debt for moving fast. Tone mapping options, probably after this, right? Somewhere like that. Actually, I think I can. I think I can just do this because it's just a member variable. So then I can just do bloom mix amount somewhere between 0 and 1. Right, let's go. Let's delete that. Delete that. Delete that. Okay, right. So let's whack this up super bright. And then let's play around with the bloom mix. So yeah, I can see it. There you go. Maybe like there. I don't know if that's now too blurry. This is going to need a little bit of tweaking. But they're starting to look pretty good now. Let's make this guy quite bright, but also make it really like narrow attenuation, so it shouldn't spread too much down there. Yeah, I think there's definitely some bloom going on there, but it's quite subtle. But I think it works quite well. Oh, this is creepy as fuck. I'm not playing this game. It just looks a little bit blurry. I don't know what the solution is, but that's really sweet. I'm really pleased with that. I think that looks really cool when you step in and it actually looks like it's glowing. Because if we use the coroutine to just flicker just like on a sine wave, just move that emissiveness up and down a little bit, then it would look like it was pulsing, which would be really cool. I don't know if I've got. Don't really have the time to do that now. What is in here? Oh, yeah, okay, cool. Nothing. Yes, that might be what we have to do. But I think for now, like I'm kind of happy to call this here. I'm really pleased with that. Like I think that's like actually looks like a really nice effect. I think, like everything, right? This is all about building out primitives that we can then tweak and work with to make something look decent in the end. Like I'm not making a horror game, right? I want to make something that's kind of atmospheric, but not like super spoopy. So we will probably want to play around with a lot of these. But I think that with the subtle like vignettes and little chromatic aberration, like it's starting to look pretty good now. Yeah, we could also add some filters just to avoid certain bits, right? If I max the bloom amount, so it'll just everything will be super blurry, right? Because you're just basically just rendering this, so you need to mix it back in with the original colors. And the problem is, the more, I guess this is the issue, right? Is the more you favor the bloom, the more blurry the image will be, because the more weight this has over the final composition. Something like that. Like I think like 0.3 was kind of good. No character model yet. I think we definitely need to make that pulse a little bit. We could try that. So that should also be a... Let's quickly batch that in as well into something we can play around with. So bloom, filter radius. What was it? It was 0.005. 0.005. Is that right? That, and then this becomes... Oh yeah, I forgot the little folding plugin I've got shows you if there's errors in the folder section, which is quite nice. Right, okay, so that should be happy. So let's go to the debugger renderer, and then we're going to do, we get two of these, bloom mix, bloom, filter radius, and this is going to be bloom, filter radius. This is going to go from 0.0 to, I guess, like 0.1. Yeah, I'm kind of happy that this is sort of working. Do you know what I mean? Like it's looking good. It's better than it was before. Each one we have, and also I kind of want to. I've really enjoyed doing these post-processing stuff. It's really been nice seeing actual visual change, but I do want to go on and do some other stuff soon. We got so much stuff to get done. Like we could spend ages tweaking this, but like I said, now that the infrastructure is there, it's just a game design problem now, right? Okay, so let's scale this up, and then let's move the blue mix up to somewhere. Oh, hang on, you've pissed off, haven't you? All right, so about there gives us that, and this will give us a. It's quite subtle. Because it actually just, I guess that's the whole point of if you don't filter it at all, it gets weaker but further out, which I guess is fine, which I guess makes sense because you're just spreading the values further. So something like that. Is it worse than just Ubuntu? Windows, mate. It's fine. Okay, I'm really pleased with that. I think I need to change the default scene so it kind of showcases these things better. I've got some refactoring I need to do anyway. I need to make the handle system a little bit more integrated. At the moment, it's just lights that handles, whereas entities need to be handles. So I might, once I've done that, I might come up with a slightly better default scene. My setup is, there's nothing wrong with my setup. I don't know why people don't like the purple fog. Look at that. It's spoopy. Oh, yeah, that's what we want. Just don't go into the light. Anyway. We'll change the window color. Right, let's make some commits. Let's go add bloom shaders. Yeah, but the thing is, I don't like horror games. I'm not building a game that I don't like. I don't want to play. Add new OpenGL function. Right. Set new uniform types, and then this is basically just like add bloom, baby. Right. Push that into the GitHub. Take that as stream 33. Right. So, yeah, it's really getting there. Now I'm really pleased with it. Right. So I'm going to, before hopefully Wednesday, tidy up a little bit of that. I need to move those things out into the scene, and then they need to be serialized. And it's just a bunch of busy work that's not really important. So I'll get that done, get this merged in. If I have time, I will do the render handle stuff, but the entity handle stuff, but that can be pushed off for later. The next thing now that it's kind of like done, question mark, is I want to, before we go any further, I want to put in some custom profiling, because again, we're building a lot of our own tooling for this. We don't have RenderDoc. We built our own rendering debugging. I think it'd be kind of fun to build some of our own profiling stuff. So the first thing we'll probably do is just create a global new and delete, and then track memory allocations. Because everything is C++, right? Like we don't really have any C libraries, so that would get us like most of the way there. Then probably do per frame allocations. Basically, we're going to build out a new ImGUI window where we'll be able to see the total amount of memory but allocated, the total that's currently allocated, like a rolling average of how much we're allocating per frame. Yeah, but then I'm pretty sure Lua has at least like technically ImGUI. No, let's see what else. But you can hook into there. You can provide them a custom allocator, which we could then just instrument. So most C libraries, I'd say, will allow you to provide custom malloc and free or new and delete, whatever, and then we could just add that to our instrumentation. So we're going to have instrumentation for memory allocation, because I think it'd be really interesting to see per frame how much we're allocating, like what the memory churn is, what we're kind of doing overall. I also then want to do GPU memory allocation, which I think is going to be interesting because we're going to have to manually track it. I don't think... And OpenGL doesn't expose any way of getting that, and I don't really want to be using like NVIDIA or any like vendor specific libraries. So we'll probably just take a good go at guessing in all of our OpenGL, like all of our OpenGL parameters should just track like what they think the memory has been allocated, not including padding and driver overhead. Tooling is just like the chuff that goes around it, right? The things that make everything work. So I've got a program which takes all the assets and converts them into a format that the game understands, right? That's a tool. We don't have any graphical debugger, so we've got those squares that you see across the bottom. That's effectively tooling that allows us to debug as we're going along. I think just having a rough idea of like how much we think we've allocated. Do you know what I mean? Like it'd be interesting to see like how many render targets, how many textures, how much space we are occupying as a rule of thumb, I guess, as like a finger in the air kind of measure. Maybe, I mean, I've never done this before. Maybe you're right. Maybe it's a waste of time. But we'd have a load of buffers and stuff, so it might be worth having a look at. Yeah, I think just because like it might be fun to set like a memory limit to try and keep below, like assuming I wanted to ship this as a game, right, I'd have to set some sort of minimum spec hardware. So if we said it has to run on 2 gigabytes of VRAM, right, it'd be good to have some idea of how close we are to that. Yeah, exactly. Yeah. So yeah, I think we're just gonna I just ballpark. So memory, like heap allocations, we can pretty accurately get. GPU allocations, I think we can just sort of like roll the dice and hope for the best. And then I also want to do a custom thread profiler as well. I think we should be able to build a profile tree of the percentage time each thread is spending in any function, and that's actually not too difficult to do. I've done it before. So I think we'll do that as well. And I think with all those things, we'll have a pretty meaty, like IMGUI set of windows, which gives us some really good information on what's going on. And then we can do physics. So that's kind of what I'm thinking. I think we're going to do some basic memory profiling, some basic GPU profiling, some basic thread profiling. Oh, this one was it. Yeah, mate, we're gonna for 2 hours. It's gonna be like head down on it. I suspect this will run through for several streams, considering I absolutely definitely have to rewrite my threading abstraction. Anyway, so. Is there any advantage of having a custom thread function profiler over using the ones in Visual Studio? Nope, you should absolutely use that. However, part of this stream is for educational purposes, and I think that's a fun thing to explore and show people if they've not done it before and have a play around with some low-level threading code. It's absolutely not. In the same way that if you want to write a game, it's not the right way to write your own renderer, like I have. If you want to profile something, it's not the right way to write your own profiler, but it's a bit of fun. How do you write tests for OpenGL functions? You don't. If you really, really wanted to, you could hook all the functions and write your own validation layer, right? So check all the state as you go along, but I think you'd basically be rewriting your own software implementation of OpenGL, and I really don't think it's worth it. You can do we have debugging, like, hang on. Whoa. Window. So I have I have a callback registered. So you can use GL debug message callback with a handler, with a custom callback. And then OpenGL will tell you all the stuff that it doesn't like, with different severity. So you can use this for logging, for like warnings, info, that kind of thing. So if OpenGL ever gives me an error, then I throw it, which then allows me to catch and handle it. So this might be something that you want. That should be I think that should be that, shouldn't it? Or is it I bet it's a macro. Disk. Right. How do I handle global in this project? Currently there is nothing global. Everything is allocated in main and then just passed around. The more I think about the future of this, the more I think we might have to have some global state. Just otherwise, we're going to end up tramping around a load of stuff up and down the various call stacks, and it might get a little bit grim. Actually, a really tiny point. I suspect the memory profiling stuff will probably have to be global. Some atomics that we use to count what's going on. So any thread at any point can say, yes, I allocated this. But yeah, basically I shove everything in scene and kind of pass scene around. But I think for profiling stuff and for metrics, I suspect that will be global, and then we just don't use it in the release build, right? So eventually we'll need some globals, but that's just life, right? Try not to go too mad with it. Great stream, I think. Good stream. Hopefully everyone had fun. I think that was pretty good. One last update for me. I'm going to go and have a beer and hang around Discord for a bit. We got a lot done. Thank you for coming along and keeping me entertained. New video soon. I've written the script. I've just not had any time to film it yet. So I'll be filming this week and then editing. So hopefully in the next week or two, there will be a new video, which will be exciting. Indeed, it is Monday tomorrow, but alas, that means we're only then 2 days away from another stream. So, could be worse. Right. Thank you, everyone. I'll see you all anon.